This section focuses on AI agents, subagents, and MCP and SDK-based workflows. We'll explore how to build safe, reviewable, and business-ready agent systems. The goal here is to understand the frameworks and practices that ensure these intelligent systems operate reliably and can be effectively managed in a business environment. Today, we're diving into the concept of an AI agent. At its core, an AI agent is a system designed to complete specific tasks. Unlike simple programs that just follow fixed rules, an AI agent uses context, tools, and instructions to make decisions and take actions. It's not just reacting blindly. It plans its moves to work effectively toward a clear goal. Additionally, a key feature of these agents is their ability to review their outputs and improve over time, making them adaptive and smarter in how they operate. This combination of understanding context, planning, acting, and learning truly defines what makes an AI agent powerful and effective. Here, we're looking at the main parts that make up an agent. An effective agent is built on a solid structure before it can function independently. The key components include the goal, which defines what the agent is trying to achieve. Instructions guide the agent's behavior, while context provides a background or environment in which it operates. Tools are the resources or capabilities the agent can use, and memory or state keeps track of past interactions or information. The output format determines how the agent presents its results, and review rules help ensure quality and consistency. All these elements come together to form a well-structured, advanced AI agent. Here we have the agent workflow cycle, which outlines the key steps an AI agent follows to complete a task effectively. It starts with understanding the task itself. This is crucial because without a clear grasp of the goal, the agent can't proceed accurately. Next, the agent gathers context, meaning it collects all the relevant information needed to make informed decisions. Then, it moves to planning the action, where it strategizes how best to tackle the task using the data it has. After planning, the agent uses the appropriate tools, which include various algorithms, APIs, or databases to execute the plan. This leads to producing the output, which is a tangible result or response generated by the agent. Finally, the agent reviews the result, checking for accuracy and effectiveness before concluding the cycle or iterating if necessary. This structured approach ensures that AI agents like advanced Claude Code perform tasks methodically and reliably. Here, we're focusing on the various use cases of agents in software development. One key area is code review, where agents can help automate the process of checking code quality and adherence to standards, making reviews faster and more consistent. Then there's bug investigation. Agents can assist in identifying and diagnosing issues more efficiently by analyzing error logs and system behavior. Test generation is another important application, where agents can automatically create test cases to ensure the software is robust and reliable. Documentation is often a time-consuming task, but agents can help generate and maintain clear and up-to-date documentation, saving developers valuable time. Release reports are critical for tracking progress and changes. Agents can compile these reports, highlighting key updates and potential risks. Repo analysis involves examining the code repository for insights, such as identifying outdated dependencies or potential bottlenecks, which agents can do quickly and accurately. Finally, client delivery summaries help keep stakeholders informed by summarizing what has been delivered and any important notes. All of these use cases showcase how advanced Claude Code and AI agents are transforming development workflows to be more efficient and effective. Here, we're comparing the characteristics of a good agent versus a weak agent in the context of advanced Claude Code and AI agents. A weak agent often suffers from risks like vague goals, too many permissions, and the absence of a review process. These factors can lead to uncontrolled actions and potential errors. On the other hand, a good agent operates under clear control, with a well-defined role, limited tools, structured outputs, and crucially, human approval at various stages. This structure helps ensure reliability, safety, and better performance. Understanding these distinctions is key to developing and managing effective AI agents. In this slide, we're looking at the concept of subagents. These are specialist agents designed to handle specific, focused tasks within a larger project. Each subagent has a clearly defined role, operating within the workflow to accomplish their particular piece of the puzzle. They work by following their own set of instructions and rules, which ensures they stay on track and deliver consistent results. Subagents become especially valuable when projects grow more complex, as they help break down tasks into manageable parts. This division of labor not only clarifies responsibilities, but also makes it much easier to review progress and troubleshoot issues along the way. Overall, subagents enhance efficiency and organization in advanced AI workflows. Let's talk about why using specialist subagents can be really beneficial. First, they offer better focus. By concentrating on specific tasks, these subagents can handle their responsibilities with greater expertise and attention to detail. This leads us to the second point: cleaner responsibilities. When duties are clearly divided among subagents, it reduces overlap and ensures that everyone knows exactly what they're accountable for. Third, it's easier to review their work. Since their roles are well defined, assessing performance or troubleshooting issues becomes more straightforward. Fourth, using specialist subagents means less confusion overall. Clear boundaries and specific roles reduce misunderstandings and miscommunication. Finally, this approach allows for more reusable workflows. Because subagents are specialized, their processes can be applied in different contexts without needing major adjustments, which saves time and resources. Altogether, these advantages make specialist subagents a smart choice for efficient and effective operations. Here, we're looking at common developer subagents, which represent different specialist roles that mirror the responsibilities found in real software teams. This setup helps keep multi-agent workflows transparent and easy to review. The key subagents include the planner agent, who organizes the tasks, the developer agent, who writes the code, the test agent, responsible for ensuring everything works correctly, the code review agent, who checks the quality and consistency of the code, the documentation agent, which handles all the necessary project documentation, and finally, the client report agent, who communicates progress and updates to clients. Together, these subagents form an advanced system within Claude Code and AI agents, improving collaboration and efficiency in software development. Every specialist subagent requires a well-defined structure to operate safely and reliably. This structure is outlined in the subagent instruction template, which includes several key components. First, we define the role of the subagent, clarifying its specific function. Next, we establish the goal to ensure alignment with the overall objective. We then specify the input needed for the subagent to perform its tasks effectively. Following that, we outline the allowed actions, which detail what the subagent is permitted to do within its role. Equally important are the restricted actions, which set clear boundaries on what the subagent must avoid. The output format is also specified to guarantee consistency in deliverables. Lastly, a review requirement is included to maintain quality control and oversight. This comprehensive template is essential for managing advanced Claude Code and AI agents, ensuring they work cohesively and responsibly. Here, we're diving into the example of subagent design specifically focused on a code review agent. The primary role of this agent is to review the files that have been changed, carefully analyzing the modifications. It performs critical checks for bugs and potential security risks, ensuring that the code remains reliable and safe. Additionally, it looks for any missing tests, which is crucial for maintaining code quality and coverage. Importantly, this agent does not make any edits to the files itself. Instead, it produces a structured review report. This report provides a clear and organized summary of its findings, helping developers understand what needs attention without altering the original code. This approach leverages the advanced capabilities of Claude Code and AI agents to enhance the code review process efficiently. Here, we're looking at what a multi-agent workflow entails. Essentially, it's a process where multiple agents work one after another in a sequence. Each agent is responsible for handling a specific stage of the workflow, which helps break down complex tasks into manageable parts. As each agent completes its work, the output is passed on to the next agent, ensuring a smooth flow of information. An important feature of this setup is that humans review the key points, adding an extra layer of oversight and quality control. This approach is especially useful for complex projects where collaboration and precision are crucial. It leverages advanced AI agents and specialized code to optimize performance and results. Here we have an example of a developer workflow that demonstrates a practical sequence involving multiple AI agents, starting from initial planning all the way to final human approval. The process begins with a planner agent who outlines the overall strategy and requirements. Next, the developer agent takes over build and implement the solution based on that plan. Once development is complete, the test agent steps in to rigorously check for any issues or bugs, ensuring quality and reliability. Following successful testing, the review agent evaluates the work for adherence to standards and correctness. Then, the documentation agent prepares comprehensive and clear documentation to accompany the final product. Finally, the process concludes with human approval, where a person reviews everything to approve the finished output. The key point here is that at each stage, the output becomes progressively clearer and safer, reinforcing the integrity of the workflow. This sequence leverages advanced Claude code and AI agents to optimize development while maintaining quality and safety throughout. In this section, we're focusing on the role of the planner agent. The planner agent performs several key functions to ensure a smooth and efficient project workflow. First, it starts by understanding the requirements thoroughly. This means the agent needs to grasp what the project demands and the objectives clearly. Next, it inspects a project structure, which involves analyzing how the project is organized, including the files and modules in place. After that, the agent identifies the files that will be affected by any changes or implementations, helping to anticipate the scope of work. Then, it defines the specific implementation steps, essentially laying out a clear roadmap for how the work will proceed. Finally, the planner agent highlights potential risks, making it easier to prepare for and mitigate any issues that might arise during development. Overall, this role is crucial for advanced Claude code and AI agents to operate effectively and deliver the desired outcomes. On this slide, we're focusing on the multi-agent developer workflow, specifically highlighting the roles of testers and reviewers. For testers, their main responsibilities include checking for expected behavior, ensuring the system handles edge cases correctly, identifying error cases, and assessing any potential regression risks that might arise from recent changes. This thorough testing helps catch issues early and maintain system stability. Meanwhile, reviewers concentrate on code quality, covering aspects like security, maintainability, and completeness of documentation. Their role is crucial to ensure the code base remains robust, secure, and easy to manage over time. Overall, this collaborative workflow between testers and reviewers enhances the development process by combining functional checks with quality assurance. Here, we focus on designing a multi-agent workflow specifically tailored for this feature. The idea is to clearly define the role of each agent involved in the process. This includes specifying what inputs each agent receives, the outputs they generate, and where approval points are needed to ensure quality and correctness. Additionally, we must establish a final delivery checklist to guarantee that all requirements are met before completion. This structured approach, using advanced Claude code and AI agents, helps streamline complex tasks by distributing responsibilities effectively, enhancing collaboration, and ensuring a smooth, organized workflow. So, what exactly is MCP? MCP stands for Model Context Protocol. Essentially, it's a framework designed to help AI systems connect seamlessly with various tools and data sources. This connection allows the AI to access external context in a structured and organized way, which is incredibly useful for more advanced workflows. Now, because MCP provides this kind of access, it also demands careful control over permissions to ensure everything operates securely and responsibly. This protocol plays a key role in advanced applications like Claude code and AI agents, enabling them to function more effectively by leveraging external information. Here, we're focusing on why the MCP, or Modular Control Platform, is so important. At its core, MCP provides agents with structured access to the key systems they need to work efficiently. This includes everything from project files and documentation to APIs and databases. It also connects business tools and internal knowledge sources, bringing all these elements together in one seamless workflow. By integrating advanced AI technologies like Claude and custom AI agents, MCP streamlines processes and enhances decision-making. Essentially, MCP acts as the backbone that supports agents, giving them the organized access they need to be effective and productive. Here, we're looking at practical use cases for the Model Context Protocol, or MCP, that show how structuring tool and data access can really enhance the usefulness of developer agents. First, developer agents can read project documentation automatically, making it easier to onboard or retrieve information quickly. Next, they can search internal knowledge bases, which helps in finding company-specific information without manual effort. They also have access to issue trackers, allowing them to pull up relevant bugs or feature requests on demand. Inspecting the database schema is another key function, so agents truly understand the data structure they're working with. Connecting with automation tools means these agents can trigger workflows or scripts, streamlining repetitive tasks. Lastly, supporting client workflow systems lets these agents fit seamlessly into existing business processes. The core idea here is that external context becomes truly usable only when access to it is well structured. By applying advanced Claude code and AI agent frameworks with MCP, we unlock powerful capabilities that dramatically improve efficiency and effectiveness for developers. Let's take a closer look at the key security questions you need to consider with MCP. First, what data is actually being accessed? Understanding the types of data involved is crucial for setting the right protections. Next, what actions are allowed with that data? Are users simply viewing it, or do they have the ability to modify or delete information? Then we ask, are secrets properly protected? This ensures sensitive information like passwords or keys are securely handled. Another important question is whether access is read-only or if right permissions are granted, as that greatly impacts potential risks. Finally, we need to know where human approval is needed, identifying points where manual oversight adds an extra layer of security. These questions form the foundation for managing access and protecting your data effectively. Here, we focus on planning an MCP-based workflow for the agent. The main goal is to carefully define several critical components to ensure efficiency and security. First, we need to identify the data sources the agent will access. This involves specifying where the data comes from and understanding its structure. Next, we establish tool permissions to control which functions and features the agent can utilize. This step is crucial to enforce security and prevent unauthorized actions. Speaking of security, we must assess potential risks, such as data breaches or misuse, and implement safeguards. Additionally, defining read and write limits helps manage the agent's access to information, ensuring it can only retrieve or modify what is necessary. Finally, integrating approval checkpoints allows for oversight and validation at key stages, providing a way to review actions before they proceed. Altogether, these elements form a robust framework for using MCP technology effectively and responsibly with advanced Claude code and AI agents. In this slide, we're diving into the concept of skills in the context of Claude, our AI system. Think of skills as reusable capability packages. These are sets of instructions and resources that allow Claude to perform specialized tasks efficiently. One of the key advantages of using skills is that they are designed to be used repeatedly across similar workflows, which helps make the outputs more consistent and reliable. Essentially, skills enable Claude to handle complex tasks more effectively by leveraging predefined processes. This forms the basis for advanced Claude code and AI agents, allowing for greater automation and sophistication in what Claude can do. Here, we're looking at the various reasons why skills are so valuable in our work. First, skills help us identify and manage repeated task patterns efficiently, which saves time and reduces errors. They also play a crucial role in understanding and optimizing business workflows, making processes smoother and more effective. Next, skills ensure we adhere to coding standards, which is essential for maintaining quality and consistency in software development. They help us follow documentation styles that make information clear and accessible to everyone involved. Skills are also important for generating reports that accurately reflect our data and insights, helping stakeholders make informed decisions. When it comes to client delivery formats, having the right skills ensures we present our work professionally and tailored to the client's needs. Finally, These skills are foundational for working with advanced tools like Claude Code and AI agents, enabling us to leverage cutting-edge technology to enhance our productivity and output. Overall, these points highlight how essential skills are in driving efficiency, quality, and innovation in our work. Here, we're looking at what makes up a strong skill. Essentially, it combines several key elements to ensure consistency and quality. First, we have the task purpose, which clearly defines why the skill exists and what it's meant to achieve. Next is the step-by-step process, laying out the precise actions needed to complete the task effectively. Then, there's a required input. This tells us what information or materials are necessary to get started. Following that, we outline the output format, ensuring that the results are delivered in a consistent and expected way. To make it even clearer, examples are provided to illustrate how the skill is applied in real situations. Finally, there's a quality checklist, which helps verify that everything meets the set standards. Together, these elements create a comprehensive package that keeps workflows on track and maintains high-quality outcomes. On this slide, we're focusing on some practical skill ideas that are essential for advanced work with Claude Code and AI agents. These skills include the code review skill, which is crucial for ensuring the quality and functionality of software before deployment. Next, the bug report skill helps in effectively identifying and communicating issues so they can be resolved quickly. Writing a clear and comprehensive README is another important skill, as it guides users and collaborators through the project. The client report skill focuses on summarizing progress and outcomes in a way that's accessible to stakeholders. The SEO audit skill is all about optimizing content to improve search engine rankings, which can be vital for visibility. Lastly, the automation SOP skill is designed to create standardized procedures for automating repetitive tasks, enhancing efficiency. Mastering these skills will significantly boost your capability to manage complex AI projects and ensure smooth collaboration and delivery. On this slide, we focus on designing a reusable skill, which is a fundamental concept when working with advanced AI agents like Claude. The idea is to create a skill specifically tailored for a given task, ensuring it can be applied repeatedly in different contexts. To do this effectively, we start by clearly defining the purpose of the skill, what it is meant to achieve. Next, we outline the workflow steps, which guide the process from start to finish. It's also crucial to specify the inputs required for the skill to function properly, as well as the expected output format, so the results are consistent and usable. Including examples helps illustrate how the skill operates in real scenarios, making it easier to understand and implement. Finally, having a quality checklist ensures the skill meets certain standards and performs reliably each time it's used. This structured approach not only enhances efficiency, but also maintains high-quality results when deploying AI solutions. On this slide, we're focusing on the concept of an agent SDK, which stands for Software Development Kit. Essentially, it's a set of tools and resources that allows developers to create programmable agent workflows. This is especially useful when building applications or automations because the SDK provides a way to connect various elements like logic, tools, and prompts in a seamless manner. By using an agent SDK, you can design systems that are not only efficient but repeatable, meaning you can deploy the same workflows multiple times without having to start from scratch each time. This is a critical foundation for developing advanced AI agents and code, helping to simplify and scale complex interactions. Here, we're looking at the key use cases for SDK workflows. First, they're perfect for repeated automation, helping you streamline tasks that need to be done over and over without manual intervention. Next, they shine in app integration, allowing different software systems to work together smoothly. They're also ideal when you need custom workflow logic, giving you the flexibility to build workflows tailored specifically to your business processes. Scheduled tasks are another great fit, enabling you to automate actions at set times or intervals. SDK workflows can connect various tools and systems, making sure everything from data to processes flows seamlessly across your tech stack. Plus, they support scalable client solutions, so as your business or customer needs grow, your workflows can grow with them. And finally, integrating advanced Claude Code and AI agents within these workflows opens up powerful possibilities for automation and intelligence-driven processes. All these points highlight how versatile and essential SDK workflows can be in modern, automated business environments. Here, we see the basic workflow logic for a programmable agent using the SDK. The process follows a clear sequence of steps that ensures smooth operation and easy management. First, the system receives input, which is the initial data or request that the agent needs to work on. Next, instructions are added. These guide the agent on how to handle the input or what actions to take. After that, relevant context is included to provide additional background or information that might affect the agent's decisions. The agent or model is then called upon to execute the task based on the combined input, instructions, and context. Once the model produces output, the system processes this result to ensure it meets the desired criteria. Finally, the processed output is either saved for future use or sent to the appropriate destination. The key principle to keep in mind is making each step explicit. This clarity makes the entire system much easier to debug, review, and scale, especially when working with advanced Claude code and AI agents. This structured approach is fundamental to building robust and efficient workflows. Here, we have several practical examples of how the SDK can be used to streamline and enhance various workflows. For instance, auto-generating client reports saves time by compiling data into comprehensive summaries automatically, freeing up your team for higher value tasks. Reviewing pull requests becomes more efficient when the SDK helps identify key changes or potential issues quickly. Summarizing support tickets transforms large volumes of customer feedback into actionable insights, improving response times and customer satisfaction. Creating documentation directly from code ensures that technical manuals stay up to date without additional manual effort. Daily log analysis provides ongoing monitoring and troubleshooting, helping to catch problems early. Lastly, generating content workflows automates routine content creation and management processes, boosting productivity. These use cases highlight how leveraging advanced Claude code and AI agents can significantly simplify complex tasks, making your operations smoother and more effective. Here, we're focusing on designing an SDK-based agent workflow tailored to a specific use case. The first step is to clearly define the inputs the agent will receive, ensuring they align with the use case requirements. Next, we'll map out the processing steps, detailing how the data moves through the system and specifying any tool calls that the agent needs to make to external services or internal functions. It's crucial to establish a consistent output format to ensure the results are reliable and easily interpretable. We also need a plan for error handling. That means anticipating potential issues and deciding how the agent should respond or recover. Finally, integrating human approval points is important for maintaining oversight, especially in critical decision-making moments. This structure not only makes the workflow efficient, but also robust and adaptable. Here, we're looking at the core purpose of the code review agent within the advanced Claude code and AI agents framework. The main goal is to thoroughly analyze code for a variety of critical factors. First, it identifies bugs that could cause the software malfunction or produce incorrect results. Next, it assesses potential security risks that might expose the system to vulnerabilities or attacks. Additionally, it checks for style issues to ensure the code adheres to best practices and remains readable and maintainable. The agent also looks for missing tests, which are essential for verifying code functionality and preventing future errors. Edge cases are another focus area, helping to guarantee the code behaves correctly in less common or extreme situations. Lastly, it highlights gaps in documentation, which is vital for keeping the code understandable and usable over time. Altogether, this comprehensive approach helps improve software quality, security, and maintainability. Here, we're focusing on defining the review scope. To ensure an efficient and thorough review process, we need to clearly outline what should be included. First, we start with the change files only, which means we concentrate our attention on the files that have been modified. Next, we consider relevant dependencies, any related files or modules that could be impacted by these changes. Then, test files come into play. It's important to review any tests that have been added or updated to validate the changes. Configuration changes are also critical, as they might affect application behavior or deployment. API or schema changes require careful scrutiny because they can impact integration points and data structures. Finally, documentation updates are essential to keep the project well documented and maintain alignment with the changes made. By clearly defining the scope, we streamline the review process and ensure nothing crucial is overlooked. In this slide, we're focusing on the structure of a code review output format, especially when using an autonomous code review agent. The key takeaway here is that a useful review report should be well organized, making it easy to scan through and validate by a human reviewer. The format typically includes several sections: a summary that gives an overview, critical issues that need immediate attention, suggested improvements for code quality, missing tests to highlight where coverage is lacking, security notes that address potential vulnerabilities, and a final recommendation summarizing the overall judgment. By breaking down the review into these clear, distinct parts, the report becomes more effective and actionable. This structured approach not only helps in identifying problems quickly, but also supports better communication between the AI agent and human developers. Here, we focus on the role of the code review agent. Its primary task is to review only the files that have been changed. The agent carefully looks for bugs, potential security risks, missing tests, and issues that might affect maintainability. Importantly, it does not modify any files. Instead, it provides a structured report summarizing its findings. This approach ensures a thorough and efficient review process, helping maintain code quality without unintended changes. Here, we focus on the importance of human review in the process. The checklist begins by asking, are the issues real? This encourages us to critically evaluate whether the problems identified truly exist or if they're false positives. Next, we consider if the suggestions provided are practical, ensuring recommendations can be realistically implemented. We also check if anything is missing, which helps us catch gaps that AI might overlook. Then, it's crucial to validate if any security concerns raised are legitimate to prevent unnecessary alarm or overlooked risks. Finally, we decide if the proposed changes should be approved. While AI review tools like advanced Claude Code and AI agents are incredibly helpful, ultimate approval remains a human responsibility. It's essential to verify all findings thoroughly before taking any action, merging code, or deploying changes to maintain the integrity and security of our systems. On this slide, we're focusing on the documentation agent purpose, which is essential for organizing and managing various types of documentation throughout a project. Let's break down the key elements one by one. First, README files serve as the introductory guide for any project, providing an overview, installation instructions, and basic usage information. They are often the first point of reference for anyone interacting with the project. Next, setup guides are critical for helping users and developers properly configure the environment and get the system running smoothly. These guides reduce setup time and prevent common mistakes. API documentation follows, which is incredibly important for developers who need to understand how to interact with the system's interfaces. Well-crafted API docs improve usability and integration. Feature summaries offer concise explanations of the system's capabilities, helping stakeholders and new team members quickly grasp what the project can do. Developer notes are more detailed internal comments and explanations intended to help maintain and extend the codebase effectively. They often include insights, rationale, and potential areas for improvement. Client handover documents are essential for transitioning the project to the client or another team, ensuring they have everything needed to maintain and operate the system without friction. Altogether, these documentation types form the backbone of project communication and knowledge transfer. With advanced tools like Claude Code and AI agents, we can automate and enhance documentation tasks, making these processes more efficient and reliable. When creating effective documentation, it's crucial to provide the documentation agent with the right context about the project. Without this, the documentation won't be as useful or accurate. There are several key inputs that we need to focus on. First, the project structure, which gives a clear overview of how the project is organized. Next, the tech stack, which outlines the technologies and tools used throughout the project. Run commands are also essential, as these explain how to execute or build a project. Environment variables must be detailed to ensure proper configuration. Then, we have the main features, highlighting the core functionalities of the project. It's equally important to document any known limitations to set the right expectations. Finally, deployment notes help guide the process of launching or updating the application. By thoroughly covering these areas, the documentation agent can generate helpful and context-rich references for users and developers alike. A strong documentation agent follows a clear and straightforward workflow to ensure thorough and accurate documentation. First, the agent inspects the repository to gain a full understanding of the codebase. Next, they identify the project's purpose to frame the documentation in context. Then, they extract the necessary setup steps so users can get started smoothly. After that, the agent documents key features, highlighting essential functionalities. Adding troubleshooting tips comes next, helping users resolve common issues easily. Finally, the documentation is reviewed carefully for accuracy to ensure everything is clear and correct. This sequence helps maintain high quality, reliable documentation that truly supports the project. On this slide, we're focusing on the role of a documentation agent, specifically in the context of a project. The key task here is to thoroughly inspect the project and create a comprehensive README file. This README should include several important sections. First, setup steps that guide new users through installing and configuring the project. Next, the run commands which explain how to start or execute the project easily. Additionally, test commands are outlined to help verify that everything is working as expected. The README should also provide a concise feature summary, highlighting the main functionalities of the project. It's equally important to describe the folder structure so users can understand how the project is organized. Troubleshooting tips are another crucial part, offering solutions to common issues that might arise. Finally, known limitations should be clearly stated to manage expectations about what the project can and cannot do. This approach of acting as a documentation agent ensures that users and developers have a clear, structured understanding of the project, making it more accessible and easier to use. Here, we're focusing on the documentation quality checklist, an essential tool to ensure that all generated documents meet high standards before they are handed off. First, it's important to review the documents for clarity, making sure that the information is easy to understand and clearly presented. Next, accuracy is crucial. Every detail must be correct to avoid confusion or errors down the line. We also need to verify that setup steps are clearly outlined, so anyone following them can proceed without issues. The commands included should be correct and tested to ensure they work as expected. We should pay special attention to any missing environment details, ensuring all necessary context is provided. Using simple language is another key point. It helps make the documentation accessible to a wider audience. Finally, including useful troubleshooting tips can save time and frustration when problems arise. This checklist is especially important when working with advanced tools like Claude Code and AI agents to maintain a consistent and professional level of documentation quality. On this slide, we're focusing on why guardrails are so important in our processes. Guardrails help us avoid several common but critical issues. For example, unsafe commands can lead to serious errors or security risks if they're not properly controlled. Wrong file edits can disrupt operations and cause data loss or corruption. Data exposure is another major concern, where sensitive information might be accidentally shared or leaked. Over-automation can sometimes backfire, causing unintended consequences if automated actions aren't closely monitored. Production mistakes, whether human or system errors, can impact our service reliability and reputation. Lastly, unapproved changes can introduce vulnerabilities and inconsistencies that are difficult to track and fix. By understanding these risks, we see why advanced tools like Claude Code and AI agents need strong guardrails to operate safely and effectively within our environments. Here, we're looking at various permission levels that control what actions a user can take within a system. Starting with Level 1, read-only access allows users to view content without making any modifications. Level 2, suggest changes, lets users propose edits, but these changes won't be applied until reviewed and approved. At Level 3, edit with approval means users can make edits, but those edits require approval before taking effect. Moving to Level 4, run safe commands permissions allow users to execute commands that are considered non-risky or safe within the system. Level 5 ramps up the restrictions, letting users run risky commands only after getting explicit approval, providing an additional layer of caution. Finally, Level 6, no production access, completely restricts users from making any changes in production environment, ensuring that sensitive environments remain secure. These permission tiers are crucial for maintaining security and operational integrity, while enabling appropriate levels of access for different roles. Here, we're focusing on the critical concept of guardrails, permissions, and human approval in managing AI agents and their actions. The key idea is that certain actions, especially those that are high risk or irreversible, must require human approval before proceeding. This is a crucial safeguard to prevent unintended consequences. For example, agents should always pause and request approval before making any irreversible or sensitive changes, especially in production environments. This includes editing many files at once, running destructive commands, changing database schemas, or accessing sensitive data. Deployments to production and modifications to security settings also demand explicit human consent. By establishing these checkpoints, we create a system of accountability and reduce the risk of errors that could impact business operations or data integrity. These human approval points act as essential guardrails that help balance automation efficiency with safety and control. On this slide, we're focusing on the guardrail prompt template, which is essential for safe and effective AI interactions. The key guidelines here are crucial. Never edit files without prior approval to avoid unintended changes, and avoid running any destructive commands that could harm the system or data. Also, accessing secrets is strictly off limits to maintain security and privacy. Before taking any action, always explain the potential risks involved so that everyone understands the implications. Finally, after completing each step, provide a review summary to ensure transparency and clarity. These guardrails help maintain control and trust when working with advanced Claude code and AI agents. Here, we emphasize that creating safe agent systems involves much more than just autonomy. First, defining the role of the agent is crucial. It clarifies what the agent is responsible for and helps set boundaries. Next, limiting permissions ensures the agent can only access what's necessary, reducing risks. Protecting secrets is vital to keep sensitive information secure. Adding approval points means that certain actions require human consent, adding an extra layer of oversight. Logging important actions helps us track what the agent has done, making the system reviewable. Finally, reviewing the final output ensures that the results meet expected standards and are safe for use. Altogether, these steps form a comprehensive safety checklist that prioritizes clear limits, continuous review, and human control to create trustworthy AI agents. Now let's focus on the section project for Lecture 40. The primary goal here is to design an AI agent system. This project will require you to create a detailed multi-agent workflow blueprint, which will serve as a deliverable. The emphasis is on developing agents that are safe, useful, and reviewable. This means the design should prioritize reliability and ethical considerations, while ensuring the agents perform their intended tasks effectively. We will rely heavily on advanced Claude code along with other AI agents, pushing the boundaries of what multi-agent systems can achieve. This project not only tests your understanding, but also your ability to build complex, trustworthy AI systems. Here we have an overview of several advanced agent systems designed to improve different aspects of project management and development workflows. The options include a code review agent system, which helps automate and enhance the code review process, ensuring code quality and consistency. The documentation agent system focuses on generating and maintaining clear and accurate project documentation. The bug investigation agent system assists in identifying, analyzing, and resolving bugs more efficiently. Next, the client report agent system automates the creation of reports tailored to client needs, improving communication and transparency. The GitHub Workflow Agent System integrates with GitHub to streamline development workflows and manage pull requests and merges more effectively. Lastly, the Content Automation Agent System handles the automation of content creation and updates. The key task here is to select one of these systems and design it with safety and reviewability in mind, ensuring it can operate reliably in real-world scenarios. This means considering how the system will handle errors, maintain security, and provide clear audit trails for all its actions. Each system offers unique benefits, so the choice depends on the specific needs and priorities of the project. The focus on advanced Claude code and AI agents highlights the cutting-edge technology underlying these solutions, making them powerful tools for modern development teams. On this slide, we're looking at the essential blueprint sections needed to build the system, specifically focusing on advanced Claude code and AI agents. First, we define the overall agent system goal, which sets the purpose and objectives of our AI agents. Next, we outline the subagent roles, detailing the specific functions and responsibilities within the system. Then we move to inputs and outputs, specifying what data the agents will receive and what results they should produce. Following that, we identify the necessary tools or MCP needs, ensuring we have the right resources to support the agents. Permissions come next, addressing access controls and security considerations. Human approval points are critical, as they mark where manual oversight or intervention is required. Finally, the process concludes with a final checklist, ensuring all components are in place before we fully build the system. Each of these sections is vital for creating a robust, effective AI agent-based system. Here, we focus on the importance of using prompts to clearly define key elements like roles, risks, approvals, and the overall workflow structure before you start building. This helps create a solid foundation and prevents confusion later on. We also suggest specific Claude prompts that guide you through designing a multi-agent workflow tailored to your use case. First, you define each subagent's role and output, ensuring every part of the process is accounted for. Next, it's critical to identify any security and permission risks to safeguard your system. Adding human approval checkpoints can further enhance control and decision-making. Finally, you create a comprehensive workflow diagram in text form to visualize and finalize your process. This structured approach leverages advanced Claude code and AI agents to build an organized, secure, and efficient workflow. This section focuses on the final project submission checklist, which is critical to ensure everything is thoroughly prepared before submission. The key takeaway here is that having a clear and well-organized structure is far more important than simply adding more agents to your workflow. This means prioritizing clarity and efficiency in your design. The checklist includes several crucial components: defining the problem your project addresses, creating a detailed agent workflow, listing all subagents involved, outlining each step of the workflow, and developing a solid tool access plan. Additionally, setting up guardrails is essential to maintain control and reliability throughout the process. You'll also want to include an example output to demonstrate the effectiveness of your project, along with ideas for future improvements. All of this together forms a complete blueprint, which should utilize advanced Claude code and AI agents to showcase sophisticated capabilities. Remember, the goal is to submit a comprehensive and polished project that highlights thoughtful structure and advanced AI integration. We've now completed Section 4, setting a strong foundation and preparing us for what's next. In Section 5, we'll dive into how to transform Claude code and AI agent skills into practical applications like freelance services, streamlined business workflows, client deliverables, digital products, and effective content systems. This next phase is all about taking the advanced knowledge you've gained and turning it into real-world value that you can offer professionally. It's an exciting step forward in mastering advanced Claude code and AI agents.